Hello dears, today we are going to discuss about the topic electric charge actually. So we initially know the basic, what is electric charge, what are the properties of the electric charge, and then we definitely deal with some numericals so that we can have a concrete knowledge of electric charge. Electric charge is actually the physical property of a particle, due to which whenever the particle will be placed in an electric field or a magnetic field or in an electromagnetic field, the charged particle will feel electric force, magnetic force or electromagnetic force respectively. So it is the physical property actually. For example, if we consider this place is to be in an electric field or a magnetic field or electromagnetic field, then whenever a particle like electron, proton will be introduced here, they will definitely feel electric or magnetic or electromagnetic force. If we place neutron in the same fields, it will never experience such forces. So neutron is not actually the charge, but electron, proton are. Okay. So what is electric charge? It is the physical property of a particle due to which whenever the particle will be placed in electric field, magnetic field or electromagnetic field, it will feel electric force, magnetic force or electromagnetic force respectively. In future we will have more knowledge that these forces are actually the Lorentz forces. Okay. So we can conclude that electron, protons are electric charge, but neutron is not. The unit of electric charge is, in CGS it will be stat coulomb or electrostatic unit or ESU, and in SI unit system it will be coulomb. There is a relationship between coulomb and electrostatic unit or stat coulomb, which is 1 coulomb is equal to 3 into 10 to the power 9 ESU. And the dimension of electric charge is I into T. Okay, now we are going to deal with the properties of the electric charges. Here we will have the concept of quantization of charge, conservation of charge, invariance of the charge, etc. So let us start the properties of electric charge. Properties of electric charge. There are basic properties actually. We know that the like charges will always repel, whereas the unlike charges will attract each other. So we will not deal with those type of statement. We will definitely deal with some unknown properties actually. First one is quantization of charge. What is quantization of charge? What does quantize means? Whenever we go to the market to purchase something, we have to pay, and the payment will be always in the integral form of 1 rupee. So in our daily life, the quantized coin is actually 1 rupee. The quantized money is actually 1 rupee. We have to pay 1 rupee, 1 into 2 rupee, 1 into 3 rupee, 1 into 4 rupee. Okay. So in case of electric charge, quantization means the basic or quantized particle will be the electronic charge. What is quantization of charge means? The charge within a body will be in the integral multiple of the elementary charge. We must deal with the elementary charge as electronic charge in our syllabus. So it can be written as the total charge, if we consider Q to be the total charge within the body, E to be the elementary or electronic charge, and N to be the integer 1, 2, 3, 4. Then the mathematical statement of quantization of charge will be Q equal to Na. We can write it as plus minus Na also, because whenever a body is releasing electrons from it, it will definitely have positive charge, and if it gains electrons, then it will have negative charge. So plus minus is actually the sense whether the body is gaining the electron or losing the electron. Now, second property is conservation of charge. Conservation of charge. We have to deal with an isolated system actually. If we consider that the system is isolated, then within that system, the total charge will remain constant. So write it as, for an isolated system, the total charge will remain constant. Okay. The second property will be invariant property of charge. Invariant property of charge. We all know that mass is not an invariant quantity, because in relativistic frame it will have a form m equal to m0 by root over 1 minus v square by c square. So mass varies in the relativistic frame. If there is such quantities which are not varying with the reference frame, then they can be called that they are invariant. So charge is independent of the reference frame, and we can conclude that charge is an invariant quantity. Why? It does not depends on the reference frame actually. That's why charge is invariant. Okay. Charge is algebraically additive. Charge is a scalar quantity, so there is no need actually to add it by the process of vector. We can easily add them algebraically as it is a scalar quantity. We consider a system. This is the system. Charge Q1 is going out from it. Q2 is also going out from it. Q3 is entering to the system, whereas Q4 is also entering to the system. So the total charge of the system will be Q1 is leaving actually. So the sense leaving will be dealt with negative sign, whereas entering will be considered to the positive. Minus Q1 plus Q2 is leaving, so minus Q2. Q3 is entering, so plus Q3. And Q4 is also entering to the system, so plus Q4. Charge is a scalar quantity, so they can be added algebraically. There are lot of properties. For example, a mass cannot have charge. It is not obvious. Whereas a charge will always have some mass with it. Charge is always transferable from body to body. These are the basic properties, and the mathematical or the fundamental properties of the electric charge are details explained here. In the next video, we deal with more important knowledge of electric charge, and after that we will definitely make a video in which these will be explained properly by numericals. Thank you.